So, here's the challenge. Build something that can stop an egg from breaking after being dropped from an incredible height. So, here's the challenge. Build something that can stop an egg from breaking after being dropped from an incredible height. But there's a twist. Humans are always constructing taller buildings. I thought about dropping the egg from the world's tallest building, but with skyscrapers constantly getting taller, I realized that strategy wouldn't last. So, I had to think bigger, a lot bigger. Outer space. A few years ago, I came up with this idea. I figured if I could use my experience landing things on planets, I could break this egg drop record. But what I didn't know was that this would turn into the hardest, most time-consuming project I'd ever attempt. Hold on tight, because this story gets intense. The concept was straightforward. Attach the egg to a rocket, then link the rocket to a weather balloon, and send it soaring into space. Once the balloon hit the edge of space, it would release the rocket, which would then plummet back toward Earth, picking up speed. As the rocket fell, it would steer itself, adjusting its fins. At 300 feet above the ground, the rocket would eject the egg, which would free-fall and land softly on a mattress we'd set up below. Seems easy, right? Well, it wasn't quite that simple when you try to land an egg from space. Understanding the science first, we had to figure out how fast an egg would fall. When something falls, it eventually hits a speed called terminal velocity. That's the maximum speed an object can fall due to gravity and air resistance balancing each other out. Humans reach a terminal velocity of about 120 miles per hour, but an egg tops out at about 75 miles per hour. So, we had to make sure the egg wouldn't break on impact, even if it was falling at that speed. We did some early tests by dropping the egg off a tall building, but the property managers weren't too thrilled with the idea of tossing eggs off the roof. So, we tried a different approach. Testing the concept, we set up a mattress, calculated the egg's fall speed, and did a test drop. The result? Cracked egg. Oops. But after a few adjustments, we figured out that the mattress could still protect the egg, even from that maximum speed. Success. One problem solved. The low-altitude trial next, we needed to test the full system, weather balloon, rocket, and all. We headed to Gridley, California, to meet up with my friend Joe, who runs BPS Space. Joe's a self-taught rocket scientist who once landed a rocket after years of trial and error. He was going to help guide the rocket as it fell. My job was to keep the egg warm because it gets really cold up there, and a frozen egg is just as bad as a cracked one. We also needed to figure out how to release the egg at the right time. We decided to test things at a lower altitude first, about 10,000 feet, before aiming for space. Things started off well, until we ran into some problems. The first attempt failed. We made sure everything was ready for launch. But then, just as we began, we faced a serious issue. Our GPS system wasn't working right. It was our fault. We'd attached a metallic streamer to the rocket to help us see it from the ground, but it interfered with the GPS signal. So, the rocket thought it was time to release the egg much too early. We had to call off the launch. There went our helium. But hey, that's how science works, trial and error. The next day, we swapped the metallic streamer for a plastic one to avoid the interference, and we tried again. But then, things still didn't go according to plan. The second attempt. Another setback, the rocket didn't rise as fast as we thought it would. This threw everything off course. After realizing the mistake, we manually released the rocket, but just as it came down, disaster struck. The rocket spun out of control. The egg didn't stand a chance. Learning and moving forward, the first failure was tough. The egg didn't survive, and neither did our spirits. But Joe wasn't discouraged. He reviewed the footage, found the issue, an error in the code, and got us back on track. After fixing the bug, we were ready to give it another shot. This time, we felt confident. But of course, we ran into more problems. The rocket veered off course again, and the egg ejected prematurely. No egg again. Back to the drawing board. A new plan. After a few more tries, and even experimenting with a backup beach ball, we decided to rethink the whole system. My friend Adam Steltzner, who helped land Curiosity on Mars, gave us a brilliant idea. Instead of aiming for a precise, missile-like landing, let's go for a more forgiving target, like the desert. A new approach. We scrapped the old design and went with something inspired by NASA's landing strategy. If NASA could land a rover on Mars, surely we could land an egg on Earth. The new setup was much more complex, but it had the potential to work. We added larger, more stable fins to the rocket and incorporated a parachute system to slow the descent. At the right moment, airbags would deploy to cushion the egg. But there was a catch. The weather balloon had to go high enough to reach space, so we needed a very specific type, zero-pressure balloons. They were fragile, expensive, and difficult to handle, but they were our only option. We inflated it slowly and carefully, but one mistake could ruin everything. And, of course, disaster struck. The balloon had a small hole. The final attempt I was crushed. But instead of giving up, I channeled that frustration into perseverance. We fixed the hole, tested everything again, and tried once more. Hours of work, countless tests, and improvements went into getting everything just right. We made our way back to the desert, determined to make it work. The launch was flawless. The balloon took off, and the rocket ascended higher and higher into the sky. As it approached the critical altitude, we were on edge, but still hopeful. The rocket hit 100,000 feet, and soon, it was on its way down. Everything seemed to be going perfectly. And at last, after 3 years of setbacks, stress, and a whole lot of patience, the rocket deployed the egg, and it landed safely. Unbroken. The mission was a success. The takeaway through all the setbacks, I learned one thing. Perseverance is everything. Every failure brought us closer to success. And while landing an egg wasn't the ultimate goal, it was about the process of figuring things out, learning, and adapting. That's what I'll carry with me moving forward. If you want to see more of how we did it, check out Crunch Labs. It's a company I started to help kids think like engineers. Every month, you get a kit to build, with lessons on the science behind it. Who knows? You might be the one to send an egg